Welcome everybody to Sustainable River Basin Management Module 4.1, Part 4. Today we will be talking about river basin management functions, and we had started talking about water allocation, a topic that we will be continuing today, specifically on water pricing. Now let's have a look first at water pricing in selected countries. This is a table that was produced by a consulting company in the year 2007, and it shows us a comparison of prices between some countries. And what we can see is in the first column the ranking in terms of prices, water prices in 2007, and the ranking in the second column of water prices in 2006 of these countries listed here. And then we have costs in euros per 100 cubic meter, or we could also say cents per cubic meter. And then we have a change from 2006 to 2007 and the 5-year trend in terms of price changes. Now what we can see here is that there are countries ranking at the top, some European countries in terms of water prices, and that, for instance, the United States here are ranking quite low in terms of water prices. But what is more interesting also is to see the changes which have occurred just within 1 year, 2006 to 2007. And there we have a few countries where we have steep increases in water prices, and in the case of Canada, for instance, which in this example is at the bottom in terms of prices, the increase has been very steep, and the same for Australia here. And when we look at the 5-year trend, we can see that in the case of Germany, prices have actually a negative trend, so costs have reduced over this 5-year period, and there's only a minor positive change within just 1 year. And then we have a few countries where we have major increases in this 5-year trend, and quite interesting are countries like South Africa or Australia again, where we know that those countries are struggling very much with water scarcity, but also with, in the case of South Africa, with social security, which in parts can be explained by the situation around water pricing. We'll come back to these phenomena later again when we have been looking into the types of pricing applied in water. Now let's just look into the water pricing and infrastructure in the case of India, which may be more interesting to you. This comes from a study conducted in 2005, and it essentially shows us some of the larger cities in India and in Southeast Asia. And we see the surface area in square kilometers in the first bottom line here. And then we see population numbers. They are, for the case of India, the first 3 columns, Chennai, Bangalore, and Hyderabad, fairly similar. And where the differences start are at the level of systems available and water charging taking place at domestic level. This happens in some of the cities, and some are only partially served in terms of metered water supply. And then when we look into the level that has been served, then it becomes much more differentiated. In the case of Chennai, we have less than 5% served with a metering system at domestic level, whereas for the case of Bangalore at that time, the coverage was 100%. And so on. We can see also here the different pricing attached to the initial block and the highest blocks. Interesting is the size of the block, initial block, which is the one costing maybe the lowest if it's an increasing block tariff. We see that those differences are quite substantial. This is a 10 cubic meter block, initial block, and here we have the other extreme of 25 cubic meter as the initial block. So what this means we will be seeing in a short minute. Let's look into the kinds of water tariffs and kinds of charges. First of all, there is what we call the single part tariff, which is meaning it's a fixed water charge, which means also that the water bill or the price that we pay for water is completely disconnected from water use. It doesn't matter how much and how often we use our water, or whether we receive water at all, we are paying a specific fixed water charge, which completely disconnected from the water consumption and the water provision. Then the second type of water tariffs or charges is the so-called volumetric charges, and one of those is the uniform volumetric charge. That means all water units are priced and consumers pay proportionally to water consumption. And then another example of the volumetric charges are increasing linear tariffs. Those are water prices which increase linear per increased water volume consumption. We talk about this in more detail now. Still another example of a volumetric charge are the increasing block tariff, which means that water price is constant per specific volumetric block and increases with the next higher volumetric block. And the opposite to this is the decreasing block tariff. That is when water price is constant for a specific volumetric block, and which is high initially and which decreases with the next higher volumetric block. Now, the third category of water tariffs or water charges are the so-called two-part tariffs. This is a tariff consisting of a fixed charge and a water use charge. So the water bill is composed of a fixed price and a price that is determined by water use. And what determines the water use could be, again, by applying a block tariff or by applying any other of these volumetric charges. And then we have as the last option that there is no charge at all, or only a minor or a symbolic minimum fee that is applied to the distribution of the water, transportation, for instance, of the water. Now let's look into the block tariffs in more detail. Those are very commonly used, and the prerequisite for a volumetric charge, such as a block tariff, is that the consumers have a metered connection to the water service, and that the water service is also delivered to the water consumer, so that there is water flowing in the pipes and water has been supplied to the consumer. Only those two actually make this worth installing as such. And then we have two options. One is the decreasing block tariff, where the largest costs occur, the decreasing, where the largest costs occur at lower consumption. And as we consume more water in terms of cubic meters, the costs will decrease, and at some point we can continue consuming and the costs will remain constant. And the other form to this is that we have the lowest costs initially, and as we increase our consumption, that cost steeply increases as well. This would be our increasing block tariff. Now let's look into the increasing block tariff in detail. Those are by far the most common charges for water services. They are used in countries where water has been historically scarce. Now, how this looks like, we have in this case quantity in cubic meter here, and here we have an example for prices per cubic meter, and then this shows us that stepwise water for the water consumption here, we will have a linear price up to a certain amount of water that's been taken and used, and then at this point we are moving into another cost category as we continue consuming additional units. Those will be charged under this price unit here. And when we reach the limit for that volumetric block, we will again move up into a higher price category, and anything that we consume beyond this amount here will be charged under this price category here for this volumetric block. Now, usually we see something like in this graph that we have 3 blocks. And how are those defined? The first block usually is called the social or lifeline block, which corresponds to the essential minimum consumption. And what the essential minimum consumption is depends very much on the social structure of an area, how many cubic meters per month would be used or are necessary to keep healthy living conditions in one household. In this example here we have 4 to 5 cubic meters per month for a 5-head household. And then we have a second block, which we would call the average or the normal block, which corresponds to the average consumption defined on the basis of a marginal cost. So this covers already some of the supply costs and the water treatment costs, but not all. And that is calculated for a typical middle income class. Again, we need to know what our consumer groups are and then define what is affordable for a typical middle income class in the specific area. Now, the third block is the high block, or the block above any of these, the 12 to 15 cubic meters per month. And the price of this third block should be designated in such a way that it provides for a full cost recovery of the services. This means that we are, through this scheme, cross-subsidizing the social and the lifeline blocks, and also partially the normal block consumers through the high block consumption. Now, the consumers can influence this. They can use as much water as they desire. So water should be provided 24 hours a day, and they pay the highest price as per rate structure. So they can influence how much they are going to consume, and whether they want to make sure they stay within this range here, or whether they can afford to stay in this range and will make sure that they're not consuming above that block, because then they would fall under the next category for the amount paid above those social and normal blocks. Now, the increasing block tariff has as an aim to provide the poor with inexpensive water. The charge is targeting the richer customers. So the higher prices are usually paid by those who can afford it. That's the theory behind it. And those who use more water pay for that. and it also assumes that those who actually use more also have the ability to pay for that. So that there's a certain sort of consumptive behavior pattern behind this that assumes that the poorest can be cross-subsidized, and whereas the higher income layers of our societies can easily afford paying the difference. Now, through this increasing block tariff, we can achieve efficient water use. However, there is a backside to this, because many people, and those are mostly the poor, are not connected to a distribution system. Often several poor households share a single metered connection, and then they fall automatically into these higher use blocks and end up paying the highest price. Exactly the opposite of what was wanted with this block tariff. And the lifeline blocks are at times defined very big, actually too big, which will lead to the formation of water markets, because people will make use of these low-cost amounts of water to resell the water to some other unserved areas. And at a much higher price. So the lifeline block can often be misused for political campaigning as well. Let's look into the decreasing block tariff. The decreasing block tariff here is showing the quantities again in cubic meter. We have here prices, some standards so that we can compare the different charging structures. And in this case, we start with a fairly high cost, the highest cost for the smallest amounts of water used. And then this decreases block in steps as we increase our water usage. The amount of water of money that we have to pay for the consumption decreases, and this reaches up to a certain level where we end up the higher our consumption will be, the lowest our price will be. The users pay different amounts for different consumption levels, and the rate per unit of water is high for the initial block only and decreases as the volume of consumption increases. So what has to be defined and probably varies is the number of blocks. There's no standard rule for this. The volumetric range and the prices per block. Now, there are advantages and disadvantages to this as well. The advantage is that industrial customers often impose low average costs because they enable the water utility, the water service provider, to capture economies of scale in water source development, transmission and treatment, which means that the larger the volumes are, the initial capital costs may be large, but the overall operational costs come to a certain optimum as we use the infrastructures properly and consume higher amounts of water, or amounts of water that were designed for that infrastructure. Now, industrial users often get water from the main supply pipes, and they do not require the installation or expansion of neighborhood distribution systems. So it favors industrial users or large-scale users. It obviously does not favor the individual households. It also doesn't encourage efficient use and ecological considerations, and really only supports a few large industrial users and not the large number of people. Now, the block tariffs can differ and can be differentiated as per the different user groups. There could be different block tariffs for domestic, for industrial or agricultural users, and this is not always transparent to what is being applied, what the different user groups are actually paying. The definition of the lifeline or normal water consumption to define those blocks are very subjective, and this means that block tariffs can be highly intransparent. Now let's look into an example again from Southeast Asia, the block tariff structure of some cities in India, but also some from Bangladesh and Sri Lanka. And what we see is that, for example, the blue line here is the case of Chennai, where we have a quite complex, very increasing block tariff structure, where the initial block is at around 10 cubic meter per month at a fairly low rate, and then we have a steep increase here and a very comparably small block, volumetric block attached to that price, which then steps up again, is again at a little bit larger and steps up again where it remains constant for, this is at about 25 cubic meters per month of water consumption. Now, what the reasons are for these volumetric blocks, the design of these blocks and the prices is not always known or easily to understand and see. The other example, extreme here, is the case of Bangalore here, where we have a fairly large initial block, and then it steps up very quickly in very small price increases into new categories. Again, this is not very easily to understand which consumer shall be supported in these cases and which ones should be the ones cross-subsidizing the costs of these lower income water consumers. Now, this just as an example to think about, and let's now move into the understanding of the fixed water charges. This means that we have a consumption that is disconnected from the price. We have a linear fixed price here, and that height of this price here can vary very much and is depending on how it's been defined. So the advantage here is that there's no metering system required. It's very simple to manage, simple administration. It can be, it often responds to people's ability to pay, and it does not require a 24/7 water service delivery in place. Now, very often is linked to a very rudimentary system, not just to have simple administration, but it's often the case when we have very rudimentary water service infrastructure in place, where we have very fast, rapidly changing land use is taking place. Then the first step would be a fixed water charge in many cases, or where we have rapid urbanization, expansion of urban areas taking place. Often this is the only response to keeping up with the extension of the water distribution system. So the charge is set without consideration of the provision costs of water supply and sewage services. It is collected once a year or sometimes twice a year from the consumers. Very often it is collected in conjunction with the fees for some other public services, such as the sewage, garbage collection, or electricity bills or so. So it's not very obvious for the water consumers very often to how much they actually pay for the water service alone. And those can vary across households or consumer classes depending on the characteristics of the consumer or the type of water connection. This means the pipe diameter could be one. It could be the distance to the next water tap, which may influence how much or what the fixed water charge is in those specific geographical areas. Now, the advantages and disadvantages of these fixed water charges are that, well, they don't provide any incentives to economize water use, to be more efficient from a consumer end or to be more efficient from the water service provider side. There's no incentive to invest in water infrastructure. There are usually very high amounts of non-accounted for water, and also water may be resold at very higher prices, which again is backfiring on maybe poor water services in the beginning, in the first place, no reliable water supplies, and those who are closer to a tap or a main line may be better served and be in a position to make profit from the poor service in the first place. So especially this keeps communities in a locked state of a low-level equilibrium trap, which means there are very few customers. Those who can afford, they will step out of the system, and left behind are the poorer portions of the society. There will be, as a consequence to this, will be low revenues, and again, as a consequence to this, there will be poor services. So it's a loop, and it's a trap in itself, which is self-reinforcing and very difficult to overcome under such a system. They are, however, common in many industrialized countries where water used to be abundant. We know now that many countries are living or have to keep up with water scarcity. So such systems in such countries are also not adequate anymore to responding to the issues of water scarcity and also climate change. Now, before ending this part, my suggestions for you to take home: you should find out what kind of water allocation system is in place where you live or where you work. See where and what the source of the water is that is supplied to your home or your company. Try to understand where the water comes from. What type of water price do you pay at home or in your company? And is there any way that you see how you can influence the water price to pay less, for instance? With this, we will continue next time, and I see you again.